From the earliest days of naval aviation, aircraft carriers have been the cornerstone of power projection. And yet, this floating airfield in the middle of the ocean has historically been the domain of highly trained pilots flying manned aircraft. Today, however, new technologies are changing the game. Unmanned aerial vehicles are proving their worth, not just in the skies over land, but on the decks of carriers at sea. In this video, we explore two pioneering programs that have reshaped America's approach to naval aviation: Northrop Grumman's X-47B and Boeing's MQ-25 Stingray. These robotic aircraft, separated by different requirements and timelines, both emerged to transform how the U.S. Navy thinks about the future of sea-based aviation. The legacy of X-47. The year was 2013 when the Northrop Grumman X-47B first made headlines. It was a bold vision made real, a stealthy, tailless, unmanned combat air system designed to take off from and land on an aircraft carrier without a pilot in the cockpit. The X-47B was created under the Unmanned Combat Air System Demonstration Program, also known as UCAS-D. Its primary objective was to develop and prove cutting-edge technologies related to autonomy, precision navigation, and integration with the tight choreography of carrier flight operations. For decades, the challenge of landing a high-performance jet on a moving, sometimes pitching flight deck had been reserved for some of the best naval aviators in the world. The X-47B was about to change that paradigm. In May 2013, the X-47B made history by performing the first catapult launch from an aircraft carrier by an unmanned aircraft. It was a carefully choreographed dance of technology and precision. The flight crew readied the drone, final checks were completed, and with a roar, the aircraft was shot into the air off the USS George H.W. Bush. Despite having no pilot on board, the X-47B soared off into the skies with the calm confidence of a well-trained veteran aviator. But the biggest test was yet to come. Taking off from a carrier is challenging, but landing on a carrier deck where everything is in motion and the margin for error is razor thin is an even greater feat. In July 2013, the X-47B made the first successful arrested landing by an unmanned aircraft on an aircraft carrier. This demonstration validated the possibility of autonomous landing procedures once thought too risky for unmanned platforms. Engineers, naval officers, and defense experts watched in awe as the X-47B executed a near-flawless approach and caught the arresting wire. It proved beyond doubt that advanced algorithms and sensors could match or even surpass the precision of a seasoned naval aviator. After that, the X-47B continued to break new ground. It performed additional carrier-based missions, refining its shipboard integration. One of the program's crowning achievements came when it demonstrated autonomous aerial refueling in 2015. Refueling in the air is challenging even for highly trained pilots. So watching a drone approach a tanker, align the probe, and refuel autonomously was a testament to the maturity of the UCAS-D technologies. By 2015, the X-47B had completed its main objectives under the UCAS-D program. With those milestones met, the Navy declared the demonstration phase a success. However, the X-47B itself did not transition into a full-scale operational program. Instead, its invaluable lessons inform the next generation of carrier-capable drones. Currently, the two X-47B aircraft remain under Northrop Grumman and Navy stewardship. They appear occasionally at test facilities, exhibitions, and are sometimes used as technology demonstrators. But for the most part, their development has concluded, and they stand today as symbols of a transformative era, one in which we learn to trust advanced autonomy to handle some of the most challenging tasks in naval aviation. They may not fly regular missions, but the X-47B's footprint extends far beyond the decks it once landed on. Its success effectively paved the way for the Navy to invest in new unmanned platforms that will shape the future of carrier aviation. One of those platforms is Boeing's MQ-25 Stingray. Enter the MQ-25 Stingray. While the X-47B showed us that autonomous carrier landings could be done, the Navy had different priorities as it turned its gaze forward. Next on the agenda was refueling. Traditionally, carrier-based fighters such as the F/A-18 have had to handle some of those buddy refueling missions themselves, taking away from their primary roles of strike, defense, and reconnaissance. Recognizing this shortfall, the U.S. Navy embarked on a mission to find a dedicated, carrier-capable aerial refueling drone. Enter Boeing's MQ-25 Stingray. This sleek, purpose-built aircraft is tasked with extending the range of the carrier air wing. Imagine being able to launch a stealth fighter like the F-35C or the F/A-18 Super Hornet and having a reliable unmanned tanker in the sky to top off the jet's mid-mission. That is the promise of the MQ-25. The MQ-25's journey began in earnest in 2018 when Boeing unveiled the T-1, a test asset designed to validate aerodynamics, flight controls, and the refueling system. Flight tests kicked off in 2019, and the development team wasted no time in pushing its capabilities. By 2021, T-1 had already accomplished several historic milestones, including successful aerial refueling of multiple platforms. 1. FA-18 Super Hornet, the MQ-25 test aircraft took off, rendezvoused in midair with the Navy Super Hornet, and passed fuel from its aerial refueling pod. 2E-2D Advanced Hawkeye, a distinct challenge given the Hawkeye's radar dome and unique aerodynamics. The MQ-25 still managed to connect with precision. 3. F-35C Lightning. 2. A stealth fighter also on track to be a cornerstone of carrier air wings, the F-35C receiving fuel mid-air from an unmanned aircraft marked another impressive step. Each successful test demonstrated the ability to reduce the refueling burden on manned aircraft and extended the overall reach of the carrier's combat power. But aerial refueling is only one facet of the Stingray story. This aircraft must also be fully integrated into carrier deck operations. That means it needs to fold its wings, move safely among manned fighter jets and support aircraft, and interface with the deck crew just like any other aircraft. Boeing and the Navy have been conducting deck handling trials to ensure that from catapult to recovery and everything in between, the MQ-25 can mesh seamlessly with standard procedures. Carrier decks are cramped, dynamic environments filled with the noise of jet engines and a constant flurry of activity. For an unmanned aircraft to maneuver, launch, and land, there autonomously requires robust software and well-choreographed procedures to maintain safety for both personnel and equipment. According to the Navy's current timelines, the MQ-25 program aims for initial operational capability in the mid-2020s. Although development schedules are never set in stone, the progress made so far underscores the Navy's commitment to getting Stingray onto the deck. In addition to its refueling role, the Navy foresees the MQ-25 having limited intelligence, surveillance, and reconnaissance ISR capabilities. This modular approach ensures that the aircraft remains relevant even in rapidly evolving threat environments. But primarily, the Stingray is all about fuel. Specifically, fuel for the jets that need to go farther, stay longer, and strike deeper. With manned fighters freed from the buddy tanking role, the carrier air wing could potentially focus on what it does best, projecting power. By handling the refueling workload, the MQ-25 promises to unlock new operational strategies. It's the logical evolution of the lessons learned from the X-47B and other unmanned projects. Connecting the dots, a new frontier for naval aviation. As we pull back the lens, we see a broader shift happening within the U.S. Navy's aviation strategy. The X-47B provided a glimpse into a future where autonomous vehicles can safely operate from carriers, complicated maneuvers, and even refuel in midair. From there, the vision pivoted to the immediate needs of the fleet, extending the range of carrier air wings and easing the burden on manned aircraft. While the X-47B and MQ-25 are not the same program, they are deeply connected through shared lessons and technologies. The X-47B's demonstration of autonomous takeoffs, landings, and refueling proved that an unmanned system could function in the high-stakes environment of carrier ops. This, in turn, gave the Navy the confidence to invest in a more specialized platform with a defined mission, the MQ-25 Stingray. Indeed, the MQ-25 might not wow onlookers with dramatic arresting landings for the first time in history because that part of the story was already written by the X-47B. Instead, the MQ-25 builds upon that success, focusing on a critical support role that directly impacts the combat effectiveness of the carrier strike group. Current status and what lies ahead. So, where are these cutting-edge programs today? X-47B. Having completed its demonstration objectives by 2015, the two X-47B air vehicles are no longer in active Navy flight test. These stealthy drones remain in custody of Northrop Grumman or the U.S. Navy, occasionally appearing for research tests or museum displays. Though they may not be front and center anymore, their legacy endures in every new unmanned platform the Navy brings aboard its carriers. MQ-25. Stingray. Boeing's MQ-25 is deep in flight testing and integration efforts. Multiple successful refueling demonstrations have proven that this drone can extend the range of numerous Navy aircraft, Future deck handling trials and further test sorties will refine the final design before the Navy declares the aircraft ready for operational service. The planned initial operational capability is targeted for the mid-2020s, making it likely to be the first operational unmanned aerial tanker in history. Looking ahead, the MQ-25 will almost certainly shape carrier operations for decades to come. By shouldering the aerial refueling burden, it frees manned aircraft to focus on strike, reconnaissance, and air defense roles. That shift could have ripple effects throughout tactical planning, strategy, and even the composition of future carrier air wings. The X-47B and MQ-25 Stingray represent two chapters in the evolving story of naval aviation. One chapter showed us that an unmanned aircraft could truly operate autonomously from a pitching carrier deck, something once considered a distant dream. The next chapter is unfolding now, as the Navy and Boeing continue testing and refining a dedicated refueling drone that will support manned fighters and open new doors for extended reach and power projection. Though each platform serves its own purpose, they are tied together by the same underlying ambition: to push the boundaries of what's possible at sea. As technology continues to advance, and as new threats and challenges emerge, the lessons gleaned from these programs will guide the Navy's approach to carrier aviation for generations. And perhaps most intriguingly, as the Navy increasingly relies on unmanned systems, the next revolution in naval aviation may not be a question of if, but when. Innovation is at the heart of progress, from the X-47B's groundbreaking autonomous carrier landings to the MQ-25 Stingray's promise of a more capable and flexible carrier air wing. The U.S. Navy continues to push forward, exploring new horizons in unmanned aviation. The flight deck, once exclusively the domain of the fearless men and women who pilot fighter jets, has now made room for a different kind of aviator, one guided by algorithms and powered by determination to redefine tomorrow's battlespace. Thank you for joining us on this deep dive. If you found this information valuable, be sure to like, share, and subscribe to Combat Tech. Stay tuned for more in-depth looks at the cutting-edge innovations shaping modern warfare, and get ready to explore the future of military technology right here on Combat Tech.